we are encountering the effect of charge. Okay, this should not exaggerations. Holding this marker, standing on the ground, running on the roads, various chemical and their reactions, our mobile communications, or different modes of communications, their corresponding antennas, all are working due to properties of charge. Overall, overall charge, electrical charge is everything. Okay बच्चों, see, now for better understanding of electric charge, their properties, one of the natural laws is found. This law first given by Gauss. Later, this is called Gauss law or Gauss theorem. Okay, see, today we are discussing about Gauss law. Brave heart, genius, young mind. For better understanding of Gauss law, we should focus on basics of a mathematical tool. So very simple mathematical tool is required here for clear perceptions or for clear understanding of Gauss law. Okay bachcho? See, so we are going to discuss first about the angle. Okay, means slight, very small scale informations you needed related to angles in this topic, in this very illustrious topic. Okay bachcho, see, so angle, do you know angle has two types? Of course, angle created by plane surface or angle lies in the plane, in the single plane, is called plane angle, or angle created by the area surface is called solid angle. Both are exactly analogous, exactly same. So if you are in position to understand plane angle, then really you capture what? The concept of solid angle. Okay, see, young mind, plane angle. Okay, see, in this, what these diagrams confirm us. Okay, see, you know, I think plane angle you are familiar from childhood. Okay, please keep alert. Angle subtended by the line, or in solid angle who subtends angle at a point? Obviously area, so please see here, this one is surface. Okay, what angle this surface makes here, creates here? How will you see? So please join this point to this point, join various points to this single point. you will feel this kind of a structure. Okay, at this point, this kind of with respect to this point, you will see this kind of a structure. This is called solid angle. Okay, bachcho, please. Now please remember, any kind of closed surface, like a sphere, like cube, like cuboid, okay, any kind of closed surface, deformed cuboid, deformed cube, है ना, irregular closed surface subtends at any point within it, subtends 4 pi steradian. Okay, very simple. See, with respect to this point, these points surround by this single point surround throughout, okay, spherically. Okay, now, so please see, whatever surface you take with respect to this point, okay, these points surrounded throughout, wholly, okay, closed, spherically type. So how much angle with respect to this point the whole surface creates inside? The answer is 4 pi steradian. Okay, so please see here. See, we are discussing first about the what curve, है ना? This is closed circumference. Okay, this is closed circumference. Here is also closed circumference. This may be polygon, this may be triangle, a square, any quadrilateral polygons, any form of closed surface. Within any point, it subtends what? Circumference subtends what? 2 pi radian or 360 degrees. How? Please see here. With respect to, okay, I am following anti-clockwise. Please remember, young man. In case of area, the direction of area with respect to point may be in these directions towards the point, or maybe away the point. Okay, please, with respect to this point, area is treated as vector quantity. With respect to this point, the direction of area you can take in this direction, or you take just radially outward or radially inward. Okay, so please see here, young mind, please see in this 2D diagram, you should follow what? Either clockwise or anti-clockwise. Okay, so we are following what? Counterclockwise or anti-clockwise in this case. Please see, if you start from here, or if you go here, so you know this this is distance, and their displacement form is this one. Okay, this path makes this amount of displacement. Okay, so both will create same angle. See, okay, again you travel whole circumference, so how much angle? Suppose I want to go, okay, if you travel on this circumference, so its displacement is this one. So this also subtends what? The sum of the total angle will become or 360 degree. Please remember, you should fragment displacement. You should fragment displacement in terms of you should fragment circumference, any kind of circumference, in terms of their displacement, in terms of their vector form. Okay, please, young man, see in this case, this may be any irregular shape, any irregular closed circumference. As I said, this may be triangle, circle, or any polygon. Okay, for outside point, how much angle it subtends? Obviously, young man, how much angle it subtends? Please see, so you should select what? One directions, maybe clockwise or anti-clockwise. So I am just taking counterclockwise. Okay, join this line first of all. 1 minute. Please look at here. Okay, if you want to go in this sense on circumference, okay, so tracing angle by this part of circumference at this point in this sense. Okay, now please see the remaining of the circumference, this one, you are moving in these directions, so angle tracing in this direction. So if this sense plus, so this sense will be minus, same values. So these whole paths subtends here angle 0, subtends at the point outside angle 0. Please see again this one. If you go on this part of circumference and if you travel on this part of circumference, so please see both subtend same angle, during this means if you follow along these directions, along this path, the angle in this direction. So now in this direction angle is this, angle is the sense of angle is in counterclockwise, or in this case clockwise. So if you sum all, you will get what, young mind? Brilliance, genius, you will get 0 angle. Please keep focus and make analogous in terms of surface also. Okay, please. Please see. Now we are formulating an equation related to what? Your plane angles. Okay, please see here. See, all means in these 3 diagrams, all part of circumference subtends at this point same angle theta. Okay, see, suppose this radius is r, or part of this length is suppose this value is dl, or it creates angle what? D theta. The d theta you write what? You know the definition of radian, when r, circumference length r, then the angle subtended by it is what? 1 radian. Okay, hence when circumference length is dl, so angle subtended by dl is what? dl by r radian. Okay, so please keep remember this formula. Okay, this is in radian. Okay, young mind, genius, please see now. Now pay attention here. Okay, please see. If you take several concentric circles, for a single circle, angle trace by the circumference proportional to what? dl, circumference length. Okay, now please see, for all concentric circles, okay, angle immaterial, these angles immaterial L and R, means independent. Please keep and make you analogous continuously. Relate these things in terms of what? Solid angle. Okay, please see here. In this case, this is dl length. Okay, this dl part of length, how much it subtend angle at P, we need to calculate. Okay, again see, our concern to find dl subtends how much angle at point P. Okay, in which case angle subtending more? Please see, this is dl length and here is point, we wish to calculate the angle. How much angle it subtends? 0. Or in which case it subtends more angle? When it's perpendicular with respect to what? Radius. Okay, so please see, as soon as you tilt and make it along with the line, this line, then it makes how much angle? 0 degree, or at the perpendicular it creates what? Big angles. Okay, so please remember, young mind, please remember, brave heart, powerful genius, please in this case Please see, a small angle we should treat as a vector, in the form of vector. Okay, please see, because this dl has two components. In this directions, dl cos theta, or in this direction, how much? Dl sin theta. So, suppose this is very small length as compared to this length. Okay, where you wish to find what? Angle, right? So please see, dl cos theta subtends angle d alpha, but dl sin theta can't subtend any angle at point P. So who subtends angle? Obviously, dl cos theta subtends angle. And suppose this point at a distance, what r? So this is angle. Okay. Now please see, this you suppose what? You could suppose this is small part of circumference. If you take any closed circumference, then total angle, how much it subtends? Okay. If you take any closed circumference, after summing up, you will get what? 2 pi radian or 360 degrees. Right, young mind? Please. Now, these whole discussions are exactly valid for solid angle also. Okay, means it valids for area also. Okay, please see here. In case of solid angle, area creates angle. Okay, please look at here. Suppose this is closed surface. Okay, previously was taking what? Previously was circumference. Okay, now we are taking what? Area. Okay, so at any point within these closed surface, this surface may be a sphere, may be cuboid, may be cube, may be any deformed kind of a structure, but closed surface, remember. Okay, please see, at inside point, how much angle this all surface subtends? Your answer is 4 pi radian. Okay, as I said, young mind, this point surrounded spherically, means this point surrounded spherically, with respect, if you take any closed surface, this point surrounds all sides. So any kind of surface if you take, if you take a sphere, cube, cuboid, any of the surfaces, please remember, all subtends here how much angle? All subtend here 4 pi radian. Okay, please see. Now this is closed surface, the inside how much angle it subtends? Please see here. To take, you will see conical type angle forms. Here d alpha. Now take in this. Okay, please take a small area, join here. Area is directed in these directions. Okay, but we need to take what? We need to take projection of area perpendicular to the radius we need to take. Okay, so please see here. All area, a small area, you should take component. Okay, you should take component, and that component must be perpendicular to what? Radius. Okay, please see. Now in this case, okay, please just analogous to your plane angles. Please, young mind, suppose here we wish to find what? Solid angle. This one is area, a small area. Suppose this one is dA. Join this line. Okay, area is tilted in this direction. So suppose with respect to the radius, suppose area makes angle, suppose theta. then in this direction how much angle it creates, component it creates, dA cos theta. Okay, right? So this one is dA cos theta, this one. Or this area how much, dA sin theta. Or this one how much, young mind genius, dA cos theta. Now please genius, dA sin theta can't subtend angle at this point. Okay, please see, as I said, or you know very well, na? With respect to this point, this area subtend huge angle, or when you tilt the area, now this area subtends angle at this point, not at this point. Okay, at this point it can't subtend angle, na? When you tilt and makes it 90 degree, it will subtend what, maximum angle at this point. Okay, please. So same analogous here we followed, है ना? So please see how much angle, this is called solid angle, है ना? Or please make it dimensionless, है ना? There was formula dl by r. Here should be dA by r square, है ना? So please write here dA cos theta divided by r square. If you integrate, so total solid angle comes what? The alpha, suppose solid angles, है ना? Whole of the circumference. So if you integrate, this value comes 4 pi steradian. Quite interesting value. Means the key factor is young mind. This P point surrounded, whatever the surface, closed surface you take, with respect to P point, P point surrounds spherically, है ना? तो how much angle whole closed surface creates, है ना? तो answer is 4 pi steradian. Okay, please you should focus on this formula. Okay, please.